keep it clean now. What I mean now, it is H2O. Gotta have it, H2O. Everything needs it, don't you know that H2O is the source of life.
Hello and welcome to Eco Alert. I'm your host Nadine Patrice, Executive Director of Operation Green Leaves. Our topic today is water quality, tap versus bottle. And I'm so pleased to have three very special guests with me today on the show to share their expertise in the field. Martha Merson, who is the Project Director at Statistics for Action at Turk in Massachusetts. And I have Mr. Raymond Diaz, who is the Chief of the Laboratory Division at Miami-Dade Water and Sewer Department, and Susan Luck, who is the founder and director of Earthworks Institute for Environmental Health, and she's also a public nurse. Today in Miami, as you know, it's very hot. Everybody is hot and thirsty. So the question on the table today is tap versus bottled water. Is the price of bottled water really worth the price? Martha, I know you always carry your bottle with you, so I want you to share with us what you think about this subject.
I mean, a question in my mind is, how did bottled water become so prevalent?
If companies want to keep growing, they have to keep selling more and more stuff. In the 1970s, giant soft drink companies got worried as they saw their growth projections starting to level off. There's only so much soda a person can drink. Plus, it wouldn't be long before people began realizing that soda is not that healthy and turned back to, gasp, drinking tap water.
I mean, you see it everywhere. You see it in vending machines. Well, it seems when you're going to buy the bottled water, oh, it's $1 or so. If you buy a big jug, it's going to last you a long time. But it really adds up. And in this short video, you can see how the cost of the tap water versus the bottled water compare.
Dance to the music, 'cause people gotta know. Keep it clean now. What I mean now, it is H2O. Gotta have it, H2O.
Bottled water does add up if you're paying for it, but people are concerned about what's in their tap water. And sort of for good reason. There are 80,000 chemicals in use in the United States. We use them for all kinds of things to make our lives more convenient. We use paint and solvents and pesticides and fertilizers, all manner of things that end up interacting with the soil and the water. And so I'd just like to say that if people do have a concern about their tap water, they should go ahead and get it tested. But before you test, really have a good idea about why and what your concern is. We have a slide that looks at the 3 different types of testing that people who are really in this field do. And they look at what's the physical feature of the water? What's the temperature like? Are there any suspended solids in it? They'll look at the chemical makeup of the water. Is there any phosphorus or nitrogen? Is there a presence of any industrial use kind of heavy metals? And then there's a whole aspect of water assessment that's biological in nature. Are there any bacteria? What are the microorganisms? What's the algae? So that's all in the surface water and also in the reservoirs that we have. So there's a lot of different ways to look at water called parameters.
Mr. Diaz, would you like to add something more to this? Because Martha was talking about in general, statewide, but we're right here in Miami-Dade County. Is there anything you would like to add to what you just said?
The public has to understand that all public water utilities in the United States are regulated through the Safe Drinking Water Act, and then also locally at the state level by the respective state regulatory agencies. And the EPA, through the Safe Drinking Water Act, has established over 100 different regulations for what's allowable and not allowable in drinking water. And then there are also many other chemicals that are not yet regulated but are required to be monitored by utilities. And there is a process that the EPA has whereby every 5 years they're required to evaluate the technology, the national occurrence of different contaminants that may have become new in terms of being detected. And they have to take a look and make determinations on the health effects of those particular compounds and whether or not they should be regulated.
Well, that was my question, because I am not an expert like some of you here. But when you said regulated, it has not been yet regulated, but required. So why can't they regulate first and then required? I mean, that's a little bit confusing.
There is a specified list of regulated compounds that utilities are required to test for right now.
And I know in Massachusetts we get an annual water report from our municipality, and it tells us what contaminants are detected or not. And I actually brought a slide from the local one here. But before we do that, I just wanted to say that lots of times when we talk about water quality, we assess that on the basis of the concentration, and it could be parts per million, or it could be parts per billion, or sometimes you'll see it as micrograms per liter. So I just brought these along to make sure that everybody's picturing the same thing when we talk about these units. So Nadine, of the containers that I just set out, which one looks like a liter to you?
Martha, I would say maybe this one.
Okay. So this is a familiar size for lots of people who grocery shop.
Yeah, the soda.
And drink soda.
Even
But
though
that's
we
the
shouldn't
2-liter size.
Oh, I can't believe
So
it.
when we're talking about liter, we're talking about this size.
Okay.
If you picture this, that's a liter. There's also one other container that's a liter. And for people who've taken science in school, they might remember that 10 centimeters by 10 centimeters by 10 centimeters is that liter volume. When we talk about parts per million, we're talking about thinking of 1 million drops in here and a concentration of, say, 1 part per million. It could be 10, it could be 200 parts per million. And let's look at the Miami Water Report from 2006. Do you get these, Nadine, in the mail? Do you look at them?
Yes, I do get them in the mail, but it's a lot of numbers, a lot of information. So I guess I should learn a little bit more, but I'll be truthful that I just put it away and look at it later. So why don't you tell us, enlighten us?
One of the first words that pops out at you will be parameter, just what we were talking about, the different characteristics of water. And as you scan down, you may see some of the parameters that are familiar. You'll see the word bacteria, you'll see arsenic, you might see fluoride or lead, and you'll see the federal levels, what the federal government gives as guidance that says the water quality for drinking cannot exceed this amount for any one of these. And then the state usually will follow those same contaminant levels. And then what I like to look for is ND. Okay, that means not detected. It means there's no observable or recordable amount of that contaminant. That could be good news.
So is that because it's too low that they can't see it?
Right. And so I brought my scale to demonstrate. So for people who, especially people who are on well water, may suspect that there's some runoff from a nearby farm, or they might suspect that that could be manure from animals, or it could be pesticides. And then they get the water tested, the results come back, and there's a lot of NDs. It looks like there's nothing there to be concerned about, but I just wanted to show you that if you add something to a scale, this one tests in grams. So
It's
one
a
reason,
zero.
it says 0. How about now?
A little bit.
It says, say, 0?
Yeah, still.
Okay.
All right. Might have to move it a little bit.
Oh, I don't think it works if you tip it.
Yeah, okay. So I really can see it, but okay, so.
Tell me when it turns to 1.
To 1, yeah.
It did.
It's 1.
Okay. So when there were 3, it was 0?
Yeah,
But are there no raisins there?
they are there, so
They
you
are
can't see it, and that's what the most dangers are, that they are there and we don't
So
know that.
sometimes you may need to ask again for the lab to use more sensitive equipment.
So you can ask.
You can. Just because there's ND doesn't mean that there's nothing there.
And it's important for people to know that they shouldn't be, it's your health, so it's your, your right to ask, to push to get the result and the information that you need. So that's very good. I know you said well water. Ray, is there a lot of wells water in Dade County, or people using well water, or probably not, maybe in Boston?
Probably less than 5% of the county is on a private well.
Susan, you think?
In our community, there's about 30,000 homes that are on well water, and my understanding is that the municipalities or the Miami-Dade County that tests water quality does not test the quality of the water for people that have well water. And they tend to have a lot more runoff because it doesn't fall into the regulations and what is done to protect our water supply. So for people with well water, and they need to know that they have well water, and often the people that have well water seem to be more rural and live closer to agricultural areas, so that they may have a lot more pesticide, fertilizer, and chemicals that come into their water supply.
Oh, thank you. That's
Those of us on municipal water are really blessed that we have people like Ray looking out for our water quality. And then before we leave that, I wanted to just go back to the cyanide and the fluoride levels that you can notice on the report. And it's just kind of striking at first because it looks like you can have more cyanide at 200 than you can fluoride at 4. And so I'd just like to say, look back at the first column under parameter and you'll see ppb. So again, parts per billion we're talking about for cyanide, and fluoride parts per million. So it's always important to know whether you're talking about this infinitesimally, microscopically small amount of parts per billion, or whether you're talking about parts per million.
Yeah, especially fluoride. I'm just going to interject a little bit. Lately, I heard about fluoride. In the past, they thought it was okay, but right now, fluoride is not good for the health, right?
Well,
Susan?
there is a lot of controversy about fluoride, and some of it was originally put in the water to protect teeth from dental caries. And just recently, the Dental Association has finally come out with some statement of questioning the safety, whereas for many years it was said to be very important. And there's been movements throughout the world, and in many areas of Europe, for example, fluoride is banned. From a health level, fluoride is in a whole other category of a halogen, which can also, not only in its chemical makeup, but can also affect metabolism, thyroid function, and might have other health implications that could be harmful over time, especially since we drink water and consume it all the time, every day.
With the water, when Ray's lab gets to test, it's not that they're testing every house, every day, and I just thought it would be helpful to talk a little bit about how that testing occurs.
Okay, well, what I'm going to do first, we're going to talk about TAP. And your department has a great campaign where we're encouraging residents to consume tap water. But first, tell us a little bit about your department and what services that you do.
Our department is a water and sewer department. Today we're focusing on the water side of it, so that's what we'll stay with. But we treat drinking water for all 2.2 million residents of Miami-Dade County. Our service area is over 400 square miles. We've got about 7,200 miles of drinking water pipe that distribute the water from the water treatment plants out to the consumers.
7,000 miles of pipes. Let's just stop and think about.
That's a lot of pipe.
Yeah,
that's Martha. We love the numbers, so you can understand.
A lot can go wrong if you have 7,000 miles of pipe. Okay.
Yes. We've got, on a daily basis, we treat an average of about 315 million gallons of water every day. Now, we saw some representations of volumes of water that are familiar to us. We saw the 2-liter bottle. A gallon is about 2 of those 2-liter bottles.
Okay.
So think about 315 million gallons of drinking water treated every single day and distributed to all of Miami-Dade County, to all 2.2 million residents. The way we get to the point of producing that water, which is regulated and safe to drink, is that we have, here in South Florida, we're very fortunate that our source of water is groundwater. It's not surface water, it's not reservoir. It is solely groundwater, which has certain advantages over surface water because there is a certain degree of natural purification that goes on in the geology in the ground. So our source water comes from wells that are located in very protected areas throughout Miami-Dade County. And these wells are each, on the average, about 80 feet deep, which is quite different from a private well in a home, which may be 15 or 20 feet deep. those private wells in homes are going to be much more vulnerable to any surface contamination of the aquifer.
Well, that's what I was going to ask. I know you're letting us know exactly how you do it, but is there any possibilities that some of that water could be contaminated to the surface water?
There's always a possibility. You can never say that there's not a
100%.
possibility, but there are engineering protocols in place on the design of the wells to prevent or minimize any potential surface water, well, surface of the aquifer type of contamination. The wells are also cased with metal casings to prevent anything that might be on the surface of the aquifer from migrating into the zone where the water is being withdrawn. So we're very fortunate to have the Biscayne Aquifer, our groundwater source here in Miami-Dade County. Basically, just to run through the treatment process, the water is pumped from the well field under pressure to the drinking water plant. At the drinking water plant, the water is softened to reduce the calcium content because hard water tends to form scale and leave deposits on fixtures in the home. The water is also disinfected with chlorine and ammonia, which is a very stable form of chlorine, which minimizes the formation of some of the disinfection byproducts that are regulated.
When people are listening and you say disinfecting the water with chlorine and ammonia, it's just like, wow, are we drinking chlorine and ammonia? So why don't you make us feel a little more comfortable to know that it's safe?
Well, it is safe. It's there's always a trade-off between disinfection and no disinfection. The trade-off is if you do not disinfect your water, you're going to have waterborne disease outbreaks like still exist in some parts of the world.
Like Haiti.
Exactly.
Like
We
Haiti
just
with the
recently
cholera.
saw the cholera incident.
Yes.
So there is a trade-off. You've got to disinfect public water supplies in order to make it microbiologically safe. And yes, the addition of chlorine or ammonia sounds like a bad thing, but the quantities that are added to the water are added to ensure the disinfection of the water, but at the same time not produce any adverse effects.
Health risk.
Right, right.
I know you're making us feel comfortable that it is safe to drink tap water. As a matter of fact, I had some 2 days ago, and I drank it, and it was really tasty. It was good. But if it wasn't in my mind of thinking, what is in that water, I would have been just perfect and fine drinking it. So it's good that you're making our listening audience comfortable about the safety of the water. But let's go talk a little bit about testing. How often, I know you have it all safe in, bringing it to the homes and stuff like that, but how often do you have to test it to make sure sometimes, and how often do you do that?
The Safe Drinking Water Act, which dictates to all public utilities what parameters have to be tested, how often they have to be tested, and what standards have to be met, defines all of the testing requirements. For some parameters, testing is required daily. For some parameters, monthly. For others, quarterly. Others, annually. It just depends on the health effects of the parameter and the prevalence of the parameter. And EPA, through many years of research and study, has determined what is the appropriate frequency of monitoring for all of the regulated parameters. Our certified drinking water laboratories perform over 170,000 tests a year on the drinking water. In addition to that, the licensed operators that operate the water treatment plants also test about 160,000, 170,000 times a year on the process part of the treatment, which includes the addition of the ammonia, the addition of the chlorine. And those tests are done every 2 hours by the operators on duty, and they are licensed and certified by the state of Florida. So there's an extreme number of tests, that go on a daily basis.
To make sure that the water is safe to drink,
that it's safe to
not
drink,
harmful.
that the right amount of chemicals are being added to produce the desired result, and also that, most importantly, that the water meets all of the established drinking water standards.
Well, I'm going to start drinking tap water, especially I'm from Miami-Dade County. So Martha, thank you. And Martha, I know Statistics for Action has some information to demonstrate this issue, in a way that they can really understand it. So why don't you share that information with us?
So just to say, on the Statistics for Action sfa.turk.edu website, people can access a guide that gives an overview of water testing issues. So that's available as follow-up for today. And the other thing that we do is just try to help people, visualize and understand what's going on. So as Ray was saying, some contaminants are tested for on a quarterly basis, and I was looking at trihalomethanes. They're a byproduct of this chlorination disinfection process, and the numbers could spike over time. Is that true? But you're also trying to make sure that that over time, as people drink 8 cups of water or something a day, that they never exceed 80. What is it? Parts per billion or parts per billion? Okay, thank you.
So
parts
you mean
per
when
billion
they drink it, not to drink too much water is what you're saying, or no?
What Martha is referring to is the regulation for these trihalomethanes, which are a disinfection byproduct.
Okay.
When chlorine is added to water that contains organics, it forms disinfection byproducts. And these are referred to as trihalomethanes.
Okay.
These disinfection byproducts are regulated because they are carcinogenic. So there is a federal regulation so that the utilities are required to test for them, again, on a prescribed regulatory basis, and see if the numbers are in compliance with the federal standard of 80 parts per billion.
So we can look at this slide and see that as you take samples in the first quarter, you find an average, and then you do that same process in the second quarter, take sample, 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 find the average, but then you average that average with the first quarter. And so you're taking this running average over time to try to see what people's exposure is really. And Ray was explaining to me that those regulations are going to change in 2012, and we're going to start looking at the average by sample site as opposed to mixing all of the samples and then finding the average. And that just really points out how political a lot of this is, and that we keep revising as the science gets better, as our instruments get better. But it pays to stay vigilant, and that if you have a concern, it's worth making that statement vocally to your politicians. They're looking at the Clean Water Act.
It's very important. Water is a very important part of our life. 70% of our body is water, and water is the source of life. So it is important to understand the water that you're putting into your body. But when you were talking about different places to test, my question to you, Ray, was, do you go to homes and take samples? How do you?
Yes, that's a very good question.
That's what I wanted to know.
The way the rules are structured and the whole monitoring structure of it is such that certain parameters are required. Monitoring is required actually at the tap of the homeowner. An example of that is the lead and copper rule, the federal lead and copper rule, where the testing to determine compliance with lead and copper levels is done at the customer tap.
Okay.
Other parameters are tested at what's referred to as the point of entry into the distribution system. That means the water physically leaving the water treatment plant.
Okay.
Certain parameters have to be tested at that point. Other parameters are tested throughout the water distribution service area, either at customers' homes, or most utilities now have secure devices that are installed in the water distribution system strategically to ensure representative monitoring of the system, because that is the water that the consumer is receiving. And these devices is where we collect our samples for the measurement of chlorine residuals, and also for probably the most important parameter that we test for on a daily basis is total coliform, which is a group of bacteria that is representative of the bacteriological quality of the drinking water. And the monitoring number is based on population served under the total coliform rule. For a utility our size, we're required to collect over 590 samples each month, every month, just for that one particular parameter. And also for the disinfectant, because the two go hand in hand. The presence of bacteria and the disinfectant, obviously if you've got the presence of the disinfectant, you're not going to have the presence of bacteria. But it's kind of a system of checks and balances to ensure total compliance and the safety of the water with regards to bacteriological contamination.
Oh, good. So, because you do go to the home, because that's one of the things I was wondering. And I want to go to Susan right now, because I know we talked before. Susan, to pick up on what Ray was saying, they do tests in the homes, and we're talking about homes. I know that sometimes residents, without knowing, they dump their medicine and chemicals or home chemicals in their water, in the drain or in the bathrooms, and that can be very harmful. So why don't you tell us a little bit more about that?
Well, you know, that's a really interesting new development in looking and analyzing water. And as much as municipalities and the county here in Miami are trying to do, very often pharmaceuticals, for example, are not tested in the water, and there really are inadequate ways to filter them out, even if they're observed, because this is a new phenomenon of the millions of chemicals exposure to the water supply that occurs daily through human waste, through down the drains, the way people dispose of their chemicals that eventually get into our water system, people that live in communities where they dump things down there, storm drains in the community that go into the local water system. So there's a lot of issues that we're now seeing. There was a recent study that made the news of over 41 million people in this country are exposed to many chemicals in their drinking water, mainly through pharmaceuticals, antibiotics, sex hormones, whether it be through natural hormones in the body or hormones that people take for hormonal replacement, for example, antidepressants and mood changing, over-the-counter medications. All of these have been picked up in more than trace amounts in the water testing. The question is, what do we do about it? So one of the things that's really important is for the public to be proactive and to realize that whatever their actions they're doing, positively or not, are going to impact not only their health, but their children, their communities.
Families. And that's what I was saying. It's scary. I don't like to use that word, but it is from what you're saying. But the good thing is that we're having this show, and hopefully as many people as possible in the audience will learn something and take steps to protect their family and everybody.
You know, a good model for that is something going on in healthcare. There are some very proactive organizations. One is called Healthcare Without Harm, and they are actually looking at how hospitals can start to gather all of their expired medications. Patients go home and there's medications left, and they're gathering them and working on how to dispose of them in a really safe way. And it would be really important for people to do the same thing rather than throwing those capsules down the toilet or those liquid cough medicines, but to capture them and find out in their community what they can do with them. It's new and it's just beginning, but if the public doesn't take action and get involved in this, we in the end are going to just impact our health, because we don't really know what happens when, even in the pharmaceutical world of people taking several medications, what happens synergistically, even at very low doses over time, when we see those ads on television of all those potential side effects. Well, what happens if we're getting very low level doses, even under the radar, day after day? And I would look at children especially.
Well, that's what was my question, because all these contaminants in the water, how the children are really affected the most, and sometimes they don't even know where they're sick, but where it's coming from. And a lot of it is coming from something very silent, because they really don't know it's a problem.
And we can't wait always till we get sick to go to the doctor, because a lot of this is low level and it becomes chronic. And just, why someone always has fatigue or headaches or some, immune dysfunction. So it's important that we all begin to really think about this in a conscious way to increase awareness.
That's very, very important. Well, time runs really fast when you're having fun, and we certainly know we had fun here, but the most important thing is we all learn something, and hopefully the audience learn a lot, and they'll take time to do something, to take steps to help themselves. So I want to thank all my guests. All three of you were wonderful here, And thanks for watching, and I'll see you next time on another edition of Eco Alert.
Source of life. You know what I mean, yeah. What I'm talking about, the source of life.